Okay, so what about the rest of these? What else would you make u equal? So looking at this one, which function looks like it's the most inside function? X cubed. So I would try x cubed first. Now if it doesn't work, you go back into time and you just try a new one. Now just do this in mental math. Okay, think about x to the third. What is the derivative of x to the third? 3x squared. There's an x squared. You see how there's an x squared right here? So that probably will work. Actually, I know it will work. But that's how you check really fast. Now this one right here is weird. So for this one, trig functions always kind of mess you up because they do this fancy thing where they put the squared right next to the trig function because they don't want it to look like the squared is on the x. So I'm going to rewrite this so that we have a sine. I'm going to put parentheses around that. Then write the cosine. And then the squared goes right there. Then there's your dx. When I do that, now I can better see. I don't know, maybe you saw it. More better see. What my u can possibly be. So u, in this case, I would choose cosine x because cosine x is inside of this squared. And so I'm going to put cosine x right here. Now you can kind of mentally check that really fast because what is the derivative of cosine x? It is negative sine. Because it's sine, I'm confident that this will probably work. Okay, we'll do some more of these examples here, guys, so you can make sure you understand them. Now, let's say you picked sine instead of cosine. And if you take the derivative of sine, you get cosine. So then that might make you think that that one would work. But when you start doing it, you'll find that it doesn't. I should just do those, huh? Yeah. Let's do them. Practice is practice. Okay, let's finish that trig one. Okay, so u equals this. So I'm going to write sine x times u squared dx. We have to get our du. So let's take this guy right here and take the derivative of it. When you take the derivative of it, you get du over dx on this side. On the right side, you're going to get negative sine x. And then you get, we'll put dx over here now, so dx is not there anymore. Now I have du equals that. Now, do we have a sine x dx? Yes, but that sine x is not negative. So can we put that negative on this side? Yeah. That's like a -1, right? And you could choose to just multiply both sides by -1, so you get negative du equals -1 du equals sine x dx, which is what we wanted. So we can take this sine x dx and substitute it out. All right. Now I normally wouldn't do this, but I'm going to write it anyways to help you guys see it. We have u squared sine x dx, and this is what we're taking out, and we're going to put in its place. What is it? U, du, and then -1 I'm going to put out in front because that's a scalar. It's just a regular number that's multiplying to it. Alright, so now I do the antiderivative of this. Let's write it up here. Negative integral. We have u squared du. I add 1 to the 2 first, and so I get u to the third, and then I divide by 3, and so I get 1/3 out in front, and then I have to multiply that result by negative, and then I have my plus c. That is almost finished. I finished the antiderivative, but I need to have it in terms of x. So what is u? U is cosine x. So I have -1/3, and I'm going to plug in cosine x, and you could write it like this. You put the 3 on top, but if you want to write it the way you would probably see it in a multiple choice problem, you would put the 3 right here and then say plus c. That one's done.